Welcome back. Today we're going to begin work on Unit 6, where the focus is on simple interest. We'll wrap that into Unit 7 eventually, where we'll switch gears to look at compound interest. So for today, the focus is simple interest. Got a lovely PowerPoint that should give us some examples and some insights into some terms. So let's get going. We'll kick it over, and I'll run a share here for this PowerPoint. We'll get into it. All right, you can notice that if you're a book follower, we can find content that relates to Unit 6. In Chapter 16 of your textbook, it's all about simple interest today. Generally, we can look in this in two contexts. We can look at it in terms of borrowing money, where the interest would be a fee, a charge, if you will, for the use of someone else's money. We could also look at it as an investment opportunity where someone's paying us interest for the use of our money. So either way works on the same formula context, and you can run through the situations basically looking for principal, rate, and time as we go through. It's a 3-section chapter. All right, so we'll introduce the simple interest formula in 6.1. We'll talk about isolating variables. I have a different feel on that. I tend to be very algebraic and not really rely so much on new formulas in 16.2. And then we'll look at the U.S. rule as it applies to partial payments in 16.3. Objectives for you to read. Again, you can find this in the PowerPoint, so I'm not going to take the time to read the slide to you. I always found that kind of insulting as a student. So some objectives from 16.1. Actually, only one objective from 16.2 and one objective from 16.3. So we'll work our way along. All right, so we're talking interest as a dollar figure, we're talking principal as a dollar figure, and we're talking rate as a percentage. Although you'll see soon that when we involve calculations, the rate tends to be written as a decimal number. So that's not difficult for us to do. We've already had that discussion. The face value, the loan or the investment, how much is it you're starting with is the principal, and how much we're going to either owe for the use of someone's money or we're going to be paid for the investment of someone using our money amounts to the interest for this particular problem. Generally, we'll look at maturity value at the end of a loan kind of situation in terms of, well, you first of all got to pay the money back that you borrowed. So you will be paying back the principal plus any interest charge. So your author calls maturity value principal plus interest. Sometimes I just say, how much do you have to pay to clear the debt or to clear the loan? And you certainly have to pay back what you borrowed in addition to the interest. And I don't know that I am a big, gigantic fan of that second form. I tend to view it more as an addition. The maturity value is at the end of the loan or at the end of the investment, how much do you have to pay to wipe it out? 16.1, it's time to calculate. So we'll be meeting our simple interest formula. Some things that we should look at. P represents principal. How much are you borrowing? Or if you're looking at an investment context, how much are you fronting to be invested? R is the rate of interest. We'll write that as a decimal. Be careful, 8% is 0.08, not 0.8. 0.8 would be 80%. And if you can get that kind of an interest rate, we'll shut this baby down. We'll all go invest every nickel we own right now. T for time. Time has to be years or parts of years. So if it's 4 months, it's 4 over 12. We'll talk about days in a little bit as we relate to ordinary interest versus exact interest. And that just has to do with how many days we're particularly looking at in the year. I represents the interest charge. It's what we're calculating. There is the simple interest formula. Interest is found by taking principal times rate times time, where interest and principal are dollar figures, rate is a decimal figure, and time is parts of years or years. Example to get us going. Barry's going to borrow money and he's going to pay it back after 9 months. And that's an 8% annual rate. So we want time to be played in years or parts of years. So be careful. We can't just enter 9 for T. So we're calculating our interest charge. There's our formula, principal times rate times time. That's a plug-in line. You see we put 5,000 in for principal, put 0.0 in it for rate, and 9 out of 12, referencing a part of a year that 9 months would be. And then we just grab a trusty calculator and punch some buttons. And we find that in this particular context, the interest charge for that loan for Barry is $300. So the next part of the problem says, what's Barry's maturity value? And remember, all that means is at the end of that 9-month period, Barry's going to pay the interest on this loan plus the original amount of the loan. All right. And we already know from previous calculations, he's paying $300 interest. So we'll be adding the two together. To square the loan, Barry's going to pay $5,300. And according to the problem, that's 9 months after he took the loan. Problem one, done. Not a whole lot of heavy stuff. Should be pretty clean. Okay. When we get days involved for time, we'll look at two possible contexts. We may use what your author calls exact interest, and that shouldn't shock you. That uses an exact 365-day year. We don't get bogged down with leap years, so 365 when you see the phrase exact. Same deal as before. Time has to be parts of years. So if we have days involved, it's going to be that number of days out of 365 if we're using exact. One thing you do want to take note of when we get dates involved, the date that the loan is actually initiated is not counted as a day. The very next day would be, but the date you pay it back, the day the loan gets wiped out, is counted as a day. So watch out for that. The loan the day is made is not counted, but the loan the day is actually paid is counted as a day. All right, so when you see exact, it's the number of days over 365. All right, here's an example for exact. We got Frank, and you'll notice that Frank's borrowing on October 5th. He's taking $40,000 at 5.25, and he's going to pay back on December 10th. So our first challenge is to track how many days pass from October 5th until December 10th. So let's attack that front. Then once we know how many days it is, it's a straight shot into the formula. All right, here we go for days. All right, I listed October, and you may remember that October's got 31 days, but we don't count the first 5. He took the loan on the 5th, so you start counting on day 6. So that's really 31 take away 5, and that's how the 26 showed up. He'll have that loan in effect all through November, which has 30 days. He's going to pay it on December 10th. So in December, that's 10 days. Remember, the day he pays is counted as a day. So the total number of days in this particular loan example is 76. Time to calculate? Yeah, let's do it. Principal times rate times time. You've got 40,000 going in for your principal. You've got going in at 0.0525. And check out that last fraction referencing time. 76 was the day count out of 365, because in this particular example, we're playing exact interest. Calculator times 40,000 times 0.0525 times 76 divided by 365. Hit equals, and that gets you your interest figure. So he's going to owe $437.26 for this particular loan. To pay it back, to wipe out the loan, the maturity value, again, just as before, it's going to be how much did he borrow in addition to what his interest charge is. So to clear the loan, it will take $40,437.26. Problem 2, up and done and in the book. Contrast exact interest with ordinary interest. And at one time, I think this was more popular because before the advent of computers and calculators, it's probably easier to do the arithmetic with 360 as a denominator relative to 365. But that's the biggest change. So if you see ordinary interest, and your book does most of the daily calculations using ordinary interest, your denominator will be 360. Again, the challenge for us is to count the days. And as before, the day the loan is started doesn't count as a day, but the day that it ends does count as a day. All right, so there's your basic run, 360 for ordinary, 365 for exact. An example for for ordinary interest, we got a borrow at $20,000, 3.75. The date that the loan is initiated was October 16th. It's going to be paid back on December 27th. Let's attack the days. All right, so for October, you may remember 31 days in that month. Knock off the first 16. So 31 take away 16 is how that 15 showed up. We're in play all the way through November, which has 30 days. We're paying on the 27th, and do remember that we include the day that the loan is paid as a day of our loan. So 27 into December. grab your trusty calculator. So we've got 72 total days. Calculating interest charge, same formula, principal times rate times time. 20 grand going in for P, 0.0375 going in for rate, and the time playing at 72 over 360 because we were asked to use ordinary interest. Again, calculator gymnastics, 20,000 times 0.0375 times 72 divided by 360. Fire it out. You got $150 interest charge. So to wipe out the loan, you're going to have to pay back the loan amount in addition to the interest charge. So it's going to cost you $20,150 to wipe the loan. That's ordinary interest. Make sure you read it critically as to whether days are involved and we're playing ordinary interest or exact interest. All right. And that shuts down video 1 for Unit 6. I'll see you back here shortly with video 2.